Okay, so this is the video explanation of our module 1. Okay, so let's start. So mathematics in nature says that nothing can beat the beauty of nature. Finding mathematics in nature at a first glance may seem less obvious. However, if one does take time to examine nature, then one can describe its beauty mathematically. So this is related also to nature. So later on, so maintindihan natin. So may mga examples. So first, we should discuss first the Fibonacci sequence. So the man behind of this sequence is Leonardo da Pisa, aka Fibonacci, taught Western Europe how to do arithmetic with Arabic numerals. So the Fibonacci sequence is the series of numbers. So these are the series or the sequence of Fibonacci. So we will begin 0, then followed by 1, 1, 2, 3, 5, 8, 13, 24, 34, and so on. So this ellipsis or the 3 dots means to infinity. So it means it is endless. So how do these numbers are formed? So how do we get 1, 1, 2, 3, 5, 8? So it says that the next number is found by adding up the two numbers before it. So the 2 is found by adding the 2 numbers before it. So how do we get 2? So we will just add the 2 numbers before it. So 1 plus 1 to get 2. Okay? So 3, how do we get 3? So the same procedure. So we will just add the 2 previous numbers. So 1 plus 2 equals 3. So the same steps for the 5, 8, 13, and so on and so forth. Okay? So example here. So how to get the next number here after the 34. So the same steps, we will just add the 2 numbers before it. So we will add 21 plus 34 to get 55. So this is the one. So 21 plus 34 equals 55. So next to 34 is 55. Okay? So here is a longer list. So ito, pag in-add natin yung 2 previous number, tuloy-tuloy, so makukuha natin tong mga sequence of numbers hanggang dito. So to get the number after 317,811, so we will just add these 2 previous numbers. So 196,418 plus 317,811 to get the next number. Okay? So make a spiral. So when we make a spiral, we will begin. So when we continue the sequence of number, so this will form a spiral. Okay, so for example, so this is the one that I'm talking about a while ago. So we will find the spiral on the nature. So as you have noticed, on the middle of the sunflower, so this is an example of the spiral. Okay, so moving on. So we have also the rule on how to get the Fibonacci sequence or the Fibonacci number. So the Fibonacci sequence can be written as a rule. First, the term are numbered 0 onwards like this. So this term are the Fibonacci sequence of numbers. Then we will number them with the counting numbers or the whole numbers starting from 0. Okay, so 0, the term number is 0. Then continuously by counting 1, 2, 3, 4, 5, 6, 7, and so on. So we will get their term numbers. Okay, so for example, the term number of 6. So term 6 is the Fibonacci sequence of term 6 is 8. So the term number of or the ninth term of the Fibonacci is 34. Okay, so we have here examples. The 8th term is the 7th term plus the 6th term. So we discussed this already a while ago. So to get the 8th term, x sub 8, so we will just add the two succeeding numbers or the two previous numbers. So 8 plus 13 equals to 29. So next to 55 is 34 plus 55. Okay? So the rule is x sub n is equal to x sub n minus 1 plus x sub n minus 2. So this is the formula, wherein x sub n is the term number n. So x sub n minus 1 is the previous term number. So x sub n minus 2 is the term before that number. Okay? So example term 9 is calculated like this. So how to get the ninth term or the x sub 9? So x sub 9 just by using the substitution method, so we will just substitute the values from this formula. Okay, so what is the nth term? So 9. So 9 minus 1 plus x sub 9 is 1. X sub 9 minus 2. So by simplifying, x 9 minus 1 equals x sub 8 plus x sub 7. Now, so we will substitute the value of the 8th term and 7th term. So what is the 8th term? So the 8th term is this one, 21. So 21 plus by substitution. So what is x7? So 7th term is 13. So 21 plus 13. Okay, so to get the total of by simplifying, so x sub 9 is equals to 34. So what is x sub 9? Is equals to 34. Okay. So moving on, so we have also the so-called golden ratio on how to get the Fibonacci sequence of numbers. So in here is a surprise. When we take any two successive one after the other Fibonacci numbers, the ratio is very close to the golden ratio. So this is the symbol of phi, this one, which is approximately 1.618034. Okay. Using the golden ratio to calculate Fibonacci numbers, and even more surprising that we can calculate any Fibonacci number using the golden ratio. So this is the formula of getting the Fibonacci sequence. Okay, so x sub n is the term in the sequence you are trying to find. Okay, so N, the position number of the term in the sequence. And phi, the symbol phi is the golden ratio, which is approximately 1.618034. Okay, so we have here an example. So how to get the sixth term or the x sub 6. So we are getting the term 6. So by using the formula, so we will just substitute the value of the golden ratio. So what is P? So this one, 1.618034 to the power of 6. So this is the nth term. So the number that we are trying to find, 6. So that's why it is to the 6th power. Minus 1 minus P. So 1 minus the value of golden ratio, 1.618034 to the power of 6. Divided by square root of 5. Okay, so when we simplify, so we will get 8.000033. Okay, to round it to the whole number, so you will just get 8. So what is the sixth term? So going back to the table below, so the sixth term is this one. The sixth term is 8. Okay, so we get the correct answer. So moving on, we can also use the formula below to get Fibonacci sequence. So I am suggesting to use this formula. So this is called the Binet's formula to get the Fibonacci sequence. So this is more accurate than the formula that we used a while ago. So I'm suggesting that it's better for you to use this formula. Okay, so for example, we will use the same example. So we will find this sixth term. So we will just use this Binet's formula. We will just substitute the value of the sixth term. So to get the sixth term, so 1 plus the square root of 5 divided by 2 to the power of 6, which is the sixth term, minus 1 minus the square root of 5 divided by 2 to the power of 6 divided by square root of 5. So to simplify, class, so always remember that we will always begin to simplify the values inside the parentheses. So we will, by using the scientific calculator, we will first get the value of 1 plus square root of 5. Then equals. So then you can see the answer on your calculator. Then you divide it by 2. After dividing it by 2, then you press again equal. Then after getting the answer, then you get the exponent of 6 or to the power of 6. Okay, so this is the value that we can get out of this value inside the parentheses. Okay, so minus, so the same procedure, so 1 minus square root of 5, then equals, then divided by 2, then equals again, then get the exponent to the power of 6. Okay, so this is the value that we will get out of these values inside the parentheses. So 0.05572809. Then bring down or divided by the square root of 5. So this one. Okay. So by simplifying, we will subtract this value from this value. Then after getting the answer, then divided by square root of 5. So we will get 8. Okay. So let us proceed to our lesson 2. So our lesson 2 is called the number patterns. So in mathematics, the number pattern is a pattern or sequence in a number series. A common relationship between all numbers is generally formed by the pattern. So example of a number pattern is 1, 3, 5, 7, 9, 11, 13. So as you have noticed, it is a pattern or a sequence of odd numbers. So this one, the number patterns represent the sequence of odd numbers. So they are also in ascending order. So first, what is a sequence? So a sequence is a listing, usually number that are in order. Okay, so example is 2, 4, 6, 8. So the first term is 2, the second term is 4, the third term is 6, the fourth term is 8. So this 3 means to infinity or endless. So it is continuous. So this is also called ellipsis. Okay. So we have here a several series or a sequence of numbers. We will identify them if they are infinite or finite or finite. When the sequence goes on forever, it is called an infinite sequence. Otherwise, it is a finite or finite sequence. Okay, so we have here examples. So 1, 2, 3, 4. So it is in ascending order. So it is very simple sequence and it is infinite because of the 3 dots that is present in the set of number, this one. Okay, so next, so the same 20, 25, 30, 35. So they are multiple of 5. So they are in order. Okay, so the ellipsis is present again, so it is infinite sequence. The third example is 1, 3, 5, 7. So now, we don't see the ellipsis anymore or the 3 dots. So it means to say it stops. So it is the sequence of the 4 odd numbers. So it is a finite sequence or finite sequence. Okay? So because the 3 dots is not present anymore. So next is the 4, 3, 2, 1. So these numbers are in order. So it is in descending order. So pababa naman siya. Kanina puro pataas. So ngayon pababa naman siya. Pero in order pa rin siya. So wala tayong makikitang dots. So this is a finite or finite sequence. So next is 1, 2, 4, 8, 16, 32. It is a sequence where every term double. So it means to say nadodouble yung sequence. So 1, 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16, 16 plus 16, 32. So next to 32 is 64 because 32 plus 32, 64. Okay, so they are in order and in ascending order. So there is a 3 dots. So it is a an infinite numbers or sequence. Okay? So, pwede rin tayong gumamit ng mga letters. So, A, B, C, D, E. So, it is the sequence of the first letter alphabetically. So, walang 3 dots. So, this is finite sequence. So, next, F-R-E-D is the sequence letter in the name Fred. So, wala uling 3 dots. So, this is finite also. So, next is 010101. So, it is the sequence of alternating zeros and 1. So, we have 3 dots here. So, it means to say it is continuous. So, it is infinite sequence. Okay? So, next. So, these are the types of number patterns. So, there are 2 common number sequence patterns. So, this is the arithmetic and geometric sequence. So, we have also special sequences of number patterns. So, these are square numbers, cubic sequence, triangular sequence, Fibonacci number. So, Fibonacci number, so we discussed this already a while ago. Okay? So, first, we will discuss the arithmetic sequence. In mathematics, the arithmetic sequence is a sequence of number in which the difference between consecutive terms is constant. This difference between consecutive terms is called a common difference. So, take note, class. So, the difference between consecutive terms is called a common difference. So, for example, consider the following arithmetic series. So, we have here 1, 4, 3, 10, 13, 16. So, as we have noticed, so their difference is 3. So, 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3, 13 minus 10 is 3, 16 minus 13 is 3. So, yung susunod dito is 19. So, mag-a-add ka lang ng 3. 16 plus 3 is 19. So, 19 minus 16 is 3. So, they have common difference. So, pare-parehas sila ng difference in between. So, it is an arithmetic sequence. Okay? So, we have here also the example number 2. So, we will identify it or we will identify it if this is an arithmetic sequence or not. So, 1, 4, 8, 11, 15, 18. So, first, the common difference of the two numbers is 3. So, next is the common difference is 4. So, dito pa lang, hindi na siya arithmetic sequence because hindi na siya common difference. So, susunod, 3 na naman. So, next, 4 na naman. So, magkakaiba-iba yung common difference na. So, this is not an arithmetic sequence. Okay? So, next is the geometric sequence. So, a geometric progression is a sequence of non-zero numbers where each term after the first is found by multiplying the previous one with a fixed non-zero number called the common ratio. So, a while ago, we have a common difference, and now, sa geometric sequence, we have also the so-called common ratio. So, for further explanation so that we can understand it very well, so we have here examples. So, 4, 8, 16, 32, 64. So, as you have noticed, class, we multiplied each of the number by 2. So, 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 34. 32 times 2 is 64. So, they have a common ratio or a common factor of 2 to get the next number. So, the next number after 64 is we will just multiply it by the common ratio 2. So, 64 times 2. So, we will get 128. Okay, so if I'm not mistaken, so the number next to 64 is 128. Okay, so basta na may magkakaparehas na multiplier na 2, so that is geometric sequence. Okay, so take note of that class. So kanina, yung difference, common difference, ngayon common ratio. Okay, so next is the square numbers. So in mathematics, an integer that is the square of an integer is a square number. For example, 16 is a square number which is a square of the number 4, denoted by 4 squared or 4 times 4. So a number that is multiplied by itself is called a square number. So we have here examples. So 1, 4, 9, 16, 25, 36, 49. So, bakit sinabing square numbers ito? So, first, so ang gagamitin natin dito is counting numbers. Magsisimula tayo sa 1, 2, 3, 4, 5, 6, 7, and so on. So, first, magsisimula tayo sa 1. So, 1 times 1 equals 1. So, anong susunod sa 1? 2. 2 times 2 equals 4. Ito. So, anong susunod sa 2? 3. 3 times 3 equals 9. So, anong susunod sa 3? 4. 4 times 4 equals 16. So, the same. Hanggang pataas ng pataas to. Susunod sa 4 is 5, 6, 7, 8, 9, 10, and so on and so forth. So, ito yung mga makukuha nyo sa mga counting numbers na minumultiply natin by itself. So, that's why it's called square numbers. Okay? So, next is the cube numbers. So, kung kanina, may square numbers, may cube numbers naman. So, ibig sabihin ng cube numbers, a number that is 3 times multiplied by itself is a cube number. For example, 27 is a cube number which is a cube root of 3, denoted by 3 times 3 times 3 equals to 27. So, example. Okay, so the cubic sequence for the natural numbers will be as follows. So these are the cubic sequence. 1, 8, 27, 64, 125, 216, 344, 512, and so on to infinity. So paano naging cube numbers? So kanina, may square number tayo. So the counting numbers is multiplied by itself 2 times. So, ngayon naman, dahil sa cube, so, we will multiply it by 3 times. So, ito, multiply 3 times. So, magsisimula ulit tayo sa 1, 2, 3, 4, 5, 6, 7, yung counting numbers. So, 1 times 1 times 1 equals 1. So, anong susunod sa 1? 2. 2 times 2 times 2 equals 8. Okay, so anong susunod sa 2? 3. 3 times 3 times 3 is 27. So, next to 3 is 4. So, 4 times 4 times 4. So, 64. So, next to 4 is 5. So, we will multiply 5 3 times by itself. So, 5 times 5 times 5 is 126. So, anong susunod sa 5? 6, 7, 8, and so on and so forth. Okay? So, that's why we call it cube numbers. Okay, so moving on. So we have also triangular numbers. Object arranged in an equilateral triangle are counted by triangular number. In a triangular arrangement with endpoints on one side, the nth triangular is the number of dots and equals to the number of the natural number from 1 to n. So the number of the pattern of dots that form a triangle will give a triangular number sequence which is as follows. So this is the sequence of triangular number 1, 3, 6, 10, 15, 21, 28, 36. So paano natin nakuha itong mga triangular sequence na to? So magsisimula ulit tayo sa 1. So makikita nyo yung in between the numbers. So yung difference nila is counting numbers. So 3 minus 1 is 2. 6 minus 3 is 3. 10 minus 6 is 4. So pataas ng pataas. 2, 3, 4, 5, 6, 7, 8. So the difference of the consecutive numbers is ascending counting numbers. Okay, so if you have noticed class, so the difference of the first is 2. The difference of the second and third number is 3. So yung susunod 4, 5, 6, 7, 8. So their difference in between is an ascending counting number. So if we represent them by dots, so magsisimula tayo sa isang 1, sa isang dot. So 1. So dahil sa 2, yung difference ng susunod, so magpa-plus tayo ng 2. So 1 plus 2, so ito magiging tatlong dots. So makukuha na tayong 3. Okay, so anong susunod na i-add natin sa 3? So mag-a-add tayo ng 3. So 3 plus 3 equals 6. So anong susunod? 4. So mag-a-add ulit tayo ng 4 sa susunod na dots. So hanggang palaki ng palaki ang triangle na yan. Okay, so anong isusunod nating i-add sa 36? So ano yung difference nila? 36 minus 28 is 7. So anong susunod na i-add natin dito? So 8. 36 plus 8 is 44. So magiging 44 dots na. So magiging palaki na ng palaki yung dots na yan. So tuloy-tuloy lang. Okay, so that's why tinawag natin triangular numbers. Okay, so next is the Fibonacci numbers. Of course, we discussed this already a while ago. So Fibonacci numbers is we get the next number by adding the two previous succeeding numbers. Okay. Next is we have your activity. Okay, so you can practice this activity. So I will give you the answer later on. Okay, so this is the first module of this prelim. Okay, so just wait for my announcement. So I will give you the second module. Okay, so thank you for listening. So until next time. Okay, goodbye class.